1. What is hydrogen solar panel? As of my last knowledge update in September 2021, there is no widely recognized technology known as a hydrogen solar panel. However, I can provide information about both hydrogen and solar panels separately to help clarify any potential misconceptions or emerging technologies that might have arisen since then. 1. Solar panels. Solar panels, also known as photovoltaic (PV) panels, are devices that convert sunlight into electricity. 1. They consist of multiple solar cells made from semiconductor materials like silicon. 1. When exposed to sunlight, these cells generate direct current, DC, electricity, which can then be converted into alternating current, AC, for use in homes and businesses or stored in batteries. 2. Hydrogen. Hydrogen is an element, and it can be used as an energy carrier rather than a primary source of energy. 2. It is often used in various applications, including fuel cells. 2. Hydrogen fuel cells are devices that generate electricity through a chemical reaction between hydrogen and oxygen, with water as the only byproduct. 2. Hydrogen can be produced using various methods, including electrolysis of water, using electricity to split water into hydrogen and oxygen, or reforming natural gas. If you are referring to a recent or emerging technology that combines aspects of both solar panels and hydrogen generation, storage, I recommend checking for the latest developments and products in the field of renewable energy and hydrogen production, storage. Technologies evolve rapidly, and new concepts or innovations may have emerged since my last update. It's worth noting that some research efforts have explored using solar power to generate electricity for water electrolysis, producing hydrogen as a clean and sustainable energy carrier. This process is often referred to as solar hydrogen production. However, it typically involves separate solar panels for electricity generation and hydrogen production equipment rather than a single hydrogen solar panel. 1. Concept of hydrogen solar panel energy? As of my last knowledge update in September 2021, the concept of a hydrogen solar panel energy system, also known as a solar hydrogen system, refers to a technology that integrates both solar panels and hydrogen production and storage. This concept aims to combine the benefits of solar energy with hydrogen generation and storage to provide a continuous and clean energy supply. Here's how it typically works. 1. Solar energy harvesting. Solar panels are used to capture sunlight and convert it into electricity through photovoltaic cells. 1. This electricity can be used to power various electrical devices, charge batteries, or drive other processes within the system. 2. Water electrolysis. A portion of the electricity generated by the solar panels is directed to an electrolyzer, a device that splits water, H2O, into its constituent elements, hydrogen, H2, and oxygen, O2. 2. This process is called water electrolysis and is typically done using proton exchange membrane, PEM, or alkaline electrolyzers. 3. Hydrogen production. The hydrogen produced through water electrolysis is collected and stored for later use. 3. It can be stored in compressed gas form, liquid form, or in metal hydride storage systems, depending on the specific design of the system. 4. Energy storage. Hydrogen is an energy carrier, and it can be stored for extended periods, making it a suitable option for energy storage. 4. When there is a demand for electricity, the stored hydrogen can be fed into a fuel cell. 5. Fuel cell electricity generation. Hydrogen is fed into a fuel cell, where it reacts with oxygen from the air to produce electricity and water as the byproduct. 5. This electricity can be used to power homes, vehicles, or any electrical devices. The main advantage of a hydrogen solar panel system is that it allows for the storage of excess solar energy in the form of hydrogen, which can then be used when the sun is not shining. This provides a way to have renewable energy available even during cloudy days or at night, addressing one of the limitations of solar power. However, it's important to note that such systems can be complex and expensive, and the overall efficiency of energy conversion and storage can vary depending on the specific technologies and components used. Additionally, advancements in battery technology and grid integration for solar energy have made traditional solar PV systems more cost-effective and efficient for many applications. Since my knowledge is based on information available up to September 2021, I recommend checking for the latest developments in solar hydrogen systems to see if there have been any significant advancements or changes in this technology since that time. 1. Advantage of hydrogen solar panel. A hydrogen solar panel system, which combines solar panels with hydrogen production and storage, has several potential advantages. 1. Energy storage. One of the primary advantages of a hydrogen solar panel system is the ability to store excess energy generated during sunny days. 1. Solar panels produce electricity when the sun is shining, but this energy can be stored as hydrogen for use when the sun is not available, such as during nighttime or cloudy days. 1. Hydrogen can be stored for extended periods, making it a valuable energy storage medium. 2. Seasonal energy availability. Hydrogen storage allows for the seasonal storage of excess energy. 2. This can be particularly beneficial in regions with seasonal variations in sunlight, ensuring a more consistent energy supply throughout the year. 3. Clean energy source. Hydrogen is a clean energy carrier, and when used in a fuel cell to generate electricity, the only byproduct is water vapor. 3. This makes hydrogen a sustainable and environmentally friendly option, especially when compared to fossil fuels. 4. Versatility. Hydrogen can be used for various applications beyond electricity generation. 4. It can be used as a fuel for hydrogen-powered vehicles, for heating, and in industrial processes. 4. This versatility makes it a valuable energy carrier. 5. Reduced grid reliance. By storing excess solar energy as hydrogen, homeowners or businesses can reduce their reliance on the grid, especially during peak demand periods or power outages. 5. This can enhance energy resilience and potentially lower electricity costs. 6. Grid support. Hydrogen solar panel systems can also provide grid support services, such as peak shaving and load leveling. 6. Excess hydrogen can be used to generate electricity during periods of high demand, helping to stabilize the grid. 7. Decentralized energy production. Hydrogen solar panel systems can be deployed at various scales, from individual homes to large industrial facilities. 7. This decentralization of energy production can contribute to a more resilient and distributed energy infrastructure. 8. Off-grid applications. In remote or off-grid locations where connecting to a centralized electricity grid is impractical or costly, hydrogen solar panel systems can provide a reliable and sustainable source of electricity. It's important to note that while hydrogen solar panel systems offer several advantages, they also come with challenges and considerations, such as the efficiency of the water electrolysis process, hydrogen storage and transportation, and the cost of hydrogen production and fuel cells. Additionally, the overall efficiency of these systems can vary depending on the specific technologies and components used. The adoption of hydrogen solar panel systems may be influenced by factors such as local climate conditions, energy needs, and the availability of incentives or subsidies. As technology advances and costs decrease, hydrogen solar panel systems may become more attractive as a renewable energy solution. 1. Disadvantage of hydrogen solar panel. While hydrogen solar panel systems offer several advantages, they also come with several disadvantages and challenges that should be considered. 1. Energy conversion efficiency. Hydrogen production through water electrolysis and subsequent electricity generation in fuel cells can be less efficient compared to directly using electricity generated by solar panels. 1. There are energy losses at each stage of the process, which can reduce the overall efficiency of the system. 2. Cost. Hydrogen production and storage technologies, including electrolysis and high-pressure or cryogenic hydrogen storage systems, can be expensive to manufacture and install. 2. This can result in a higher upfront cost for hydrogen solar panel systems compared to traditional solar PV systems. 3. Complexity. Hydrogen solar panel systems are more complex than standard solar PV systems. 3. They involve multiple components, such as solar panels, electrolyzers, hydrogen storage, and fuel cells, which require maintenance and may increase the likelihood of system failures or inefficiencies. 4. Energy losses. The conversion of solar energy to hydrogen and back to electricity involves energy losses at each step. 4. These losses can reduce the overall efficiency of the system, making it less energy efficient compared to other energy storage methods like batteries. 5. Hydrogen transportation and storage. Hydrogen is a low-density gas, which means that it requires specialized storage and transportation infrastructure. 5. This infrastructure can be costly to develop and maintain. 5. Leakage of hydrogen during storage and transportation can also be a concern. 6. Safety concerns. Hydrogen is highly flammable and can be challenging to handle safely. 6. Special safety measures and precautions are necessary to store, transport, and use hydrogen. 6. Safety standards and regulations must be adhered to. 7. Limited infrastructure. As of my last knowledge update in September 2021, the infrastructure for hydrogen production, distribution, and refueling is less developed compared to electricity grids and battery charging infrastructure. 7. This can limit the practicality of hydrogen for certain applications. 8. Environmental impact of hydrogen production. The environmental benefits of hydrogen depend on how the hydrogen is produced. 8. If hydrogen is produced from fossil fuels without carbon capture and storage, it can contribute to greenhouse gas emissions. 8. Green hydrogen, produced using renewable energy sources, is a cleaner option but may still have some environmental impacts, such as water usage in the electrolysis process. 9. Technology maturity. Hydrogen production and storage technologies are still evolving, and their commercial maturity is not as advanced as some other renewable energy and storage technologies like lithium-ion batteries. 9. This can lead to uncertainties in terms of performance, reliability, and long-term maintenance. 10. Competing technologies. Advances in battery technology and the decreasing costs of lithium-ion batteries have made them a more attractive option for energy storage in many applications, potentially reducing the appeal of hydrogen solar panel systems. It's essential to consider these disadvantages alongside the advantages when evaluating the suitability of a hydrogen solar panel system for a specific application or location. The choice between hydrogen-based systems and other renewable energy and storage solutions should be based on a careful analysis of the specific requirements and constraints of the project. Additionally, it's important to stay updated on developments in hydrogen technology, as research and innovation may address some of these disadvantages over time. Top of form.